So the problem reads, Willow the Witch dusts her crystal ball with her silk scarf, causing the ball to become charged with 5.0 times 10 to the negative 9th coulombs. Willow then stares into the crystal ball, and the wart on the end of her nose experiences an electric field strength of about 2,200 newtons per coulomb. How far is the tip of her nose from the center of the crystal ball? Okay, so in order to solve this problem, we have to use two equations. The first one being the electric field equals the force over the charge, at which we have both already. So we just plug them into the equation to solve for the amount of force we have. We have our charge right here, and we have our electric potential equals force over the same amount of charge. And those end up canceling out to give us our force of 1.1 times 10 to the negative 5th newtons. And then the other equation we have to use is force equals a certain semi-random constant times the first charge and second charge over the amount of distance squared. So we end up using this equation right here. We have our force right here times our constant times the one charge that we had squared over distance squared. Now in order to solve for distance, we have to get d squared by itself. So in order to do that, we have to multiply it on both sides, giving us the distance squared next to this force, and then put the charge and the force right here on this side. So then we go all the way up to here, where we have this same thing, where we have to square the force first in order to get this amount that we see right here. And then we end up having our force and our distance squared and our certain semi-random constant and this certain random answer we got right here. Now what we got to end up doing is we have to multiply these two because they're in parentheses and you know, PEMDAS. So we get to this equation here where we have we have our force, we have our d squared, and then we have the value that we came up with by multiplying these two. So to get d squared by itself, we have to divide this whole part right here by the force to get d squared by itself, which we have to do on both sides because, you know, math. So dividing this amount by the force right here gives us this amount, which is actually, because that's squared, but that doesn't matter. So what we end up doing anyways is that we have to square this amount to get the actual distance, which is 0.14 meters. There you go.